0.05, 0.05, 0.05, 0.05, 0.05. Hello trainers and researchers, this is Professor's Aids, the place where we learn how to do research Pokemon style. And today we're gonna talk about p-values. As you can hear, super excited about that, mostly because it's very, very controversial. There are actually entire schools and movements right now, especially recently, that's this debate on whether or not we should use p-values like at all. That's one thing. The other thing is how we should interpret them. If we should be a little bit more flexible in our interpretations. And needless to say, it's been a doozy, mostly because a lot of people, when they start doing research or just get into this, maybe they're not that familiar with statistics as well, and they look at it in a more like it's a bit more algebraic maths kind of thing, which means that 1 plus 1 equals 2. That's a very clear-cut solution, like there's not much debate about that. But nope, stats, it's actually subjective, at least up to a point, and that's what's causing the entire debate. But anyway, I will stop the ranting a bit now and just talk about p-values, just p-values without the drama, okay? Let's take it from the beginning. The p-values, whenever they're used in inferential statistics, when we want to evaluate a result of a study. Okay, what is a p-value? So a p-value is a number between 0, larger than 0. It can be like minuscule. It can be like 0.00001 for all we care, but it's a little bit larger than 0, and up to a little bit lower than 1. So it could be 0.9999999. Again, it could be very big, it could be almost 1, but lower than 1. So it's in between those values. Why? Because it's a probability. So between 0 and 1, between 0 and 100. But a probability of what exactly? Oh, that's where the good part starts. If you've watched the video on the null hypothesis, you will remember that what we're trying to prove when doing a study is that nothing is going on. That whatever difference we may have found in our sample, if we're looking in difference in means, for example, or whatever, that difference that we found is purely due to chance. And sometimes that can happen because it's just a sample. I mean, if you want to see if male and female Buizels, for example, have different mean weight in Pokemon Legends Arceus, you can gather a few female and a few male Buizels, and even if there is no real difference in the two groups, which we may know from data mining, you can still find a little bit of a difference. And why? Well, because chance. But when is that chance a little bit too much? A little bit too sus, if you will? Well, that's what the p-value is for. So basically, it's the probability that we got the result that we did in our study purely due to chance. To try and phrase it a bit better, because some people might have an issue with the word probability, essentially what we're saying is that if we did the exact same study 100 times, so we gathered female and male Buizels 100 times from the same exact spots, the same exact time, so all the other possible variables are the same, exactly the same, and we miraculously managed to just replicate the study exactly. The only thing that is different is the Pokemon that we caught, because of course that would be different. It's chance. So if we did that study 100 times, how many times do we expect to get the same difference as a result? So if the p-value is 0.7, for example, that would be 70%. So 70 out of 100 studies, we would expect to get that same difference due to chance. And that's a lot. So that means that there shouldn't be any real difference in the populations, because look, we did that and we got a little bit of a difference, but 70 out of 100 times we would get that difference. So hey, no difference between the two populations. Same weight, those Buizels, male, female, doesn't matter, right? But if the p-value is 0.01, that would be that the result we get would be, we would expect in 1% of the studies, so in 1 out of 100 studies. And now that is a little bit sus, right? Right? It is in fact very unlikely to get that difference. In fact, 1 out of 100 times, that's, I mean, it's still possible, not likely. That's what makes that p-value a bit more, let's say, researcher friendly. That means that we have found something, and that probably means that we can, publish a paper or something like that, which researchers tend to like. So usually the magic number here is 0.05, so 5 out of 100 studies. That's the magic number. That's when we say, okay, if we found that result, if we are due to find this result, this chance, this difference, in less than 5 out of 100 studies, then we say that, oh, well, hold on, this is likely that it is not due to chance, that there is an actual difference going on here. To come back to the null hypothesis, that it is likely that, in fact, we need to reject the null hypothesis, which says that everything is the same, and adopt the alternative hypothesis, which says that there is an actual difference in the groups. I hope you can see how nicely that ties up with our previous video, so how well it all goes together. So 0.05 is the usual threshold. It's the dream for most, because that's what we set. So it's completely subjective, and that's where all the drama comes in, all the debate. It's like, why should we say that 5 out of 10 studies isn't chance, and 6 out of 100 is chance? So what makes it so different? Because we can have a 0.04 p-value and say, oh, that is quite rare, so it must be more than chance, right? So we must have an actual difference going on here. There's evidence, there's definitely evidence, and then we go with a 0.06 p-value and say, ooh, we can find that result in 6 out of 100 studies pure to dumb luck. So of course there's nothing actual going on here. And say, but how? I mean, why? That doesn't make much sense if you look at it that way, right? If you have a very stiff threshold, wherein in fact it's a little bit more, soft. Some people like to use 0.01 p-value as their threshold, so that's also a thing that some papers or some schools might use, and that kind of works. It just sort of it penalizes you a little bit more, in fact. So it says, ooh, I'm still not sure, 2 out of 100 studies and could be chance. Ooh, I'm not sure, I might be in those 2 studies. So I'm not gonna say I found something. So that's what it forces you to do. But still, it's not good enough, because again, you have 0.02, and you say, oop, nothing going on, and then you have 0.009 and say, oh, there's definitely some difference here. It's like, is it really that much different though? And I hope you see where this sort of lacks in logic. Well, I don't really want to take sides. I did study in a school in Windon, let's say, where they did have a certain opinion about p-values and a certain way they should be interpreted. But honestly, just because it's subjective, I don't want to straight up reject any sort of school of thought. Because they're all valid, and in a way everybody's right and everybody's a little bit wrong as well, just because there's not really hard mathematical threshold in this case. I'm just gonna note some things that can be done. One thing is not use p-values at all, so just use different sort of modeling and or different sort of metrics as well. A lot of people have moved from inferential statistics to predictive modeling as well, so there's something else. I mean, they are used for different things, but it is something to consider if you really, really, really don't like p-values and you just feel that the results are unreliable or not good enough, at least for you, mentally. And the other thing that could be done is have some sort of thresholds for the interpretation to say, okay, there is not enough evidence if the p-value is large, so if the p-value is in between the middle values, it's 0.5 or such, to say, okay, there might be some evidence. I don't remember the exact thresholds myself, to be honest, but then the lower the p-value gets, essentially, you say, oh, there's strong evidence that there might be an actual difference. So maybe we might have some actual findings in the study. So if we have 0.03, there might be some evidence that there is a difference, but if we have 0.0001, there might be strong evidence that we have some actual findings that are not due to chance in our case. There's a lot to be said on the subject, and I'm definitely not going to cover it in 10-15 minutes, and I am a little bit aware that I've been rambling for a bit now. I hope that this makes sense. In the end, if you're a beginner, what you need to remember is that what the p-value is and when it's used, in inferential statistics, and just have a vague idea about the thresholds that are used. Again, the 0.05, sometimes 0.01. And for now, that's good enough, basically, because the more stats heavy, deep theory stuff could be done by somebody else in your group, basically. So don't worry about that. Just have a vague understanding for now, and that there is some sort of drama. So depending on what paper you might try to publish, they might have different requirements. So always keep that in mind as well. Anyway, that's it for now. Hope it all made sense. Take a deep breath, keep gaming, keep training, keep researching, and see you soon.